There is something fundamentally broken with the way we heat our homes today. For over 1,000 years, heating was about building smart structures that worked with fire, not against it. It sustained entire communities through brutal Scandinavian winters, kept massive halls warm where hundreds gathered, and required nothing more than wood and stone. But today, that same word heating describes a complex mechanical system that hemorrhages energy, creates hot and cold zones, and leaves you freezing the moment the power goes out. In 1200 AD at Lofoten in northern Norway, archaeologists have reconstructed a Viking chieftain's longhouse that stretches 83 meters long. That's 272 feet of interior space, roughly the size of a modern shopping center. Inside this massive timber cathedral, one central fire provided all the heat for over 100 people during the harshest months of the year. No ductwork, no blower fans, no thermostats. The building itself was engineered to move warm air through convection loops that kept everyone comfortable. They thrived on it through winters that would cripple modern infrastructure. No heating bills that spike with every cold snap. No duct systems bleeding 20 to 30% of your heated air into crawl spaces and attics. No mechanical failures that leave families shivering in their own homes. Fast forward to today, the average American home loses conditioned air faster than a Viking ship takes on water. Energy Star reports that typical forced air systems waste up to 30% of heated air before it even reaches the rooms. Cut the power to a modern house at 14 degrees outside, and within 6 hours your indoor temperature drops below freezing. Your great-grandfather heated a farmhouse through blizzards that lasted weeks without a single kilowatt of electricity. So what the hell changed? The answer isn't that modern materials are inferior or that Vikings had some mystical understanding of fire. The answer is that the heating industry shifted from building passive thermal systems to selling you mechanical dependence. They traded structural intelligence for equipment sales, maintenance contracts, and monthly energy bills. The Viking chieftain wasn't primitive. He was using applied physics that the HVAC industry desperately wants you to forget. Before we go deeper, drop a comment and tell us, how much did your last heating bill shock you? Do you have rooms that never seem to get warm no matter how high you crank the thermostat? Let us know below, because what you're about to discover will change how you see every modern heating system and show you why your house is fighting against physics instead of working with it. Let me walk you through what I discovered when I started measuring the actual performance of modern heating systems and why your house feels like a thermal disaster zone despite costing a fortune to heat. Picture this familiar winter scene. Your thermostat reads 72 degrees. Your living room feels like a sauna, but walk down the hallway and your back bedroom is an icebox. You're wearing shorts in the kitchen while your kids pile on blankets in their rooms. This isn't bad luck or poor insulation. This is the predictable result of a fundamentally broken approach to moving heat through buildings. Here's the dirty secret the HVAC industry doesn't advertise on those glossy brochures. Energy Star research reveals that typical forced air systems lose between 20 and 30% of heated air before it ever reaches the rooms you're trying to warm. Think about that for a moment. Nearly 1/3 of the energy you're paying for disappears into crawl spaces, attics, and wall cavities. But the bleeding doesn't stop there. Even perfectly sealed ducts lose heat through conduction, warming the duct walls and whatever cold space surrounds them instead of your living space. You're essentially paying to heat your crawl space while your bedroom stays cold. The reason modern homes feel uncomfortable, even with supposedly advanced technology, comes down to compartmentalized floor plans that create isolated thermal islands. Each room becomes its own microclimate, but you've got one thermostat trying to control this maze of different temperatures. The system was designed for convenience, not physics. When that mechanical system fails, and it will fail, your comfort collapses instantly. Cut the power during a winter storm, and within hours your modern home becomes uninhabitable, while our ancestors rode out weeks-long blizzards without missing a meal or losing a night's sleep. The industrial logic behind this failure becomes clear when you follow the money. The heating industry didn't optimize for resilience, longevity, or graceful failure. They optimized for speed of construction, cheap installation costs, and serviceable components that need regular replacement. filters to change, blowers to repair, thermostats to upgrade, ductwork to maintain. It's a subscription model disguised as home comfort. Our ancestors didn't push heated air through a spaghetti factory of sheet metal, hoping it would arrive where needed. They built the structure itself to move heat intelligently, using natural convection and thermal mass. You can start diagnosing your own thermal failures right now. First, trace where your ducts run. If they're snaking through attics or crawl spaces, you're hemorrhaging heat into unconditioned space. Second, identify your biggest comfort complaint rooms. These are usually at the end of the duct runs, where pressure has dropped and heated air barely arrives. Third, listen for the telltale signs of duct leaks: dusty supply registers, whistling return grills, and rooms that never match what your thermostat claims the house temperature should be. These aren't minor inefficiencies. These are symptoms of a heating strategy that works against physics instead of with it, and they're costing you hundreds of dollars every winter while keeping you perpetually uncomfortable. Let me show you the real financial devastation of modern heating systems, and why you're essentially paying to warm empty space while your family shivers in drafts that shouldn't exist. The hidden costs go far beyond what shows up on your monthly energy bill, and once you see the math, you'll understand why heating bills have become a major household expense while comfort has actually gotten worse. The comfort cost hits you first through what I call thermostat wars. When your living room is 78 degrees but your bedroom never gets above 65, you're forced to crank the thermostat higher just to get minimal warmth in the cold zones. This overheats the areas near your heating system while still leaving distant rooms uncomfortable. Families end up running space heaters in bedrooms, blocking vents in overheated areas, and constantly adjusting thermostats trying to find some mythical setting that works for the whole house. You're paying for a system that creates the very problems you're then forced to solve with more energy consumption. The energy cost reveals the mathematical insanity of modern duct systems. Energy Star confirms that 20 to 30% of heated air never reaches its destination, lost through leaks in poorly sealed ductwork. Add conduction losses as heated air travels through cold attics and crawl spaces, and you've built an expensive pipeline that warms everything except your living spaces. Picture this. If you're spending $1,500 heating your home each winter, up to $450 of that is literally heating outdoor air, attic space, and the interior of your walls. You're paying premium prices to warm areas you never occupy, while the spaces you actually live in remain uncomfortably cold. The health cost emerges from air movement systems that distribute more than just heated air. National Renewable Energy Laboratory research warns that poorly designed duct systems don't just impact comfort and efficiency, they can affect indoor air quality by unintentionally distributing pollutants, allergens, and moisture problems throughout the house. Your forced air system becomes a highway for dust, pet dander, and whatever contamination exists in your ductwork or unconditioned spaces where ducts run. Vikings dealt with smoke from their central fires, but they weren't pretending their air system was perfectly clean. Modern systems promise clean air delivery while often making indoor air quality worse through cross-contamination and inadequate filtration. The fragility cost shows up during grid instability and fuel price spikes. When winter storms knock out power, your modern heating system becomes useless infrastructure. When natural gas prices double overnight, your monthly heating bill can jump from manageable to catastrophic without warning. You're completely dependent on continuous fuel supply and electrical power to maintain basic comfort in your own home. You can start quantifying these hidden costs immediately. Weather strip your exterior doors and measure the temperature difference. Seal major air leaks around your attic hatch, recessed lights, and plumbing penetrations, and track your energy usage. Balance your return airflow by ensuring every room has adequate return paths and monitor which rooms improve first. These aren't minor tweaks. These are emergency repairs to a heating strategy that's been designed to fail expensively while keeping you perpetually uncomfortable and financially dependent. Let me share the scientific evidence that proves Viking heating systems actually worked, measured with modern instruments by researchers who lived through entire winters using these ancient methods. This isn't romantic speculation about the past. This is hard data from experimental archaeology that validates the physics while honestly revealing the trade-offs our ancestors accepted. In 2011, researchers conducted an extraordinary experiment at two reconstructed Viking Age houses in Denmark. For 13 weeks during winter, volunteers actually lived in these structures, cooking, sleeping, and heating exclusively with central wood fires, just as Vikings did over 1,000 years ago. They measured everything: indoor temperatures, air quality, carbon monoxide levels, and particulate matter. The European Archaeological Research Center published their findings, and what they discovered validates everything I've been telling you about passive thermal systems. Near the central fireplaces, carbon monoxide levels averaged 16 parts per million, while particulate matter measured 3.4 milligrams per cubic meter. These numbers tell a story of remarkable heating efficiency paired with serious air quality challenges. The structures maintained livable temperatures throughout brutal Danish winters using nothing but wood fires and intelligent building design, but the occupants paid for that warmth with significant smoke exposure. The National Museum of Denmark explicitly notes that traditional Viking houses lacked chimneys and windows, using only roof holes for smoke escape, and that indoor smoke levels could be severe during winter months when structures were sealed against cold. Here's where I build credibility by admitting the obvious. This wasn't a romantic scented candle experience. Living with central fires meant breathing smoke daily, accepting soot on surfaces, and dealing with air that would violate modern indoor air quality standards. Vikings weren't ignorant of these problems. They simply prioritized survival and thermal efficiency over pristine air quality, making calculated trade-offs that kept them alive through Ice Age conditions. But here's the breakthrough insight. We can keep the physics while eliminating the pollution. The key concept is thermal mass, which means dense materials that absorb heat during fire, operation, and slowly release that stored energy as temperatures drop. Modern building science confirms that thermal mass acts like a thermal battery, smoothing temperature swings and extending comfort hours after active heating stops. Vikings used stones, earth, and heavy timber construction around their fires to create this effect. We can achieve the same thermal storage using masonry heaters, wood stoves surrounded by stone or tile mass, sealed combustion systems that draw outside air for burning, and balanced ventilation that manages indoor air quality without destroying heating efficiency. You can prove these principles work in your own home right now with two simple tests. Place one thermometer high on a wall and another near floor level. Then measure the temperature difference during evening hours to see thermal stratification in action. Take a cheap incense stick and use it to visualize airflow patterns, watching how smoke moves to reveal natural convection currents and draft paths. Any combustion appliance affects indoor air quality, so carbon monoxide alarms and code compliance aren't optional. But these measurements will show you the same physics Vikings used to heat massive structures with single fires, proving that intelligent building design trumps mechanical complexity every single time. Let me trace the exact timeline of how we abandoned building intelligence for mechanical dependence and why this shift represents one of the greatest betrayals in construction history. This wasn't gradual evolution or technological improvement. This was a deliberate pivot from passive resilience to profit-driven energy addiction that has left millions of families financially vulnerable and physically uncomfortable in their own homes. The fundamental logic shift happened during the post-war housing boom. Traditional building wisdom prioritized structure-first heating, thick walls, intelligent orientation, thermal mass, and natural airflow management. Builders understood that the envelope itself should provide thermal stability, with heating systems serving as backup during extreme conditions. But the new industrial logic flipped this relationship completely. Build fast, cheap shells using lightweight materials, then fix comfort problems by installing mechanical equipment. Speed of construction and standardized components became more important than thermal performance or long-term durability. Ducted forced air systems became the standard not because they were superior, but because they were profitable and scalable. The Department of Energy now acknowledges that typical duct systems lose 20 to 30% of conditioned air through leaks, holes, and poor connections. Add conduction losses as heated air travels through cold spaces, and you've created permanent energy hemorrhaging that affects every home built using this method. These aren't manufacturing defects or installation errors. These are predictable consequences of prioritizing installation speed over thermal integrity. The industry knew the losses were inevitable, but the losses became someone else's problem. Yours. The corporate incentives behind this shift become clear when you follow the business model. Traditional masonry heating and passive solar design created structures that required minimal ongoing inputs. Once built properly, they provided decades of reliable comfort with nothing more than fuel and basic maintenance. But ducted systems created recurring revenue streams, equipment sales, replacement parts, service contracts, filter changes, duct cleaning, and system upgrades every 15 to 20 years. The heating industry transformed from building permanent solutions to selling temporary fixes that require constant feeding. The standardization also served mass housing development. Cookie-cutter floor plans, identical equipment packages, and assembly line construction methods reduced skilled labor requirements while increasing profit margins. Builders could frame houses faster, install identical HVAC systems in every unit, and move on to the next subdivision. The fact that these systems would underperform for decades wasn't their problem. They were building for quick sales, not lifetime performance. If you're trapped in a home with ducted heating, you can still apply Viking-style priorities to minimize the damage. First, seal duct leaks using proper mastic sealant and verified connections, not just tape that fails over time. Energy Star guidelines emphasize that leak sealing provides the biggest improvement for the lowest cost. Second, insulate any ducts running through unconditioned spaces like attics or crawl spaces to reduce conduction losses. Third, if you're planning renovations, prioritize moving ductwork inside conditioned space where heat loss serves your living areas instead of empty cavities. These aren't minor tweaks. These are emergency repairs to reverse decades of intentional design failures that have made comfortable heating expensive while keeping you dependent on systems engineered to waste energy. Let me break down the staggering financial and physical costs of modern heating that go far beyond your monthly energy bill and show you why families are spending more money than ever while living less comfortably than our ancestors who heated with nothing but wood and stone. The real expense isn't just what you pay the utility company, it's the cascade of problems created by systems designed to heat air instead of people, volume instead of living spaces, and mechanical complexity instead of thermal intelligence. The comfort cost starts with thermostat warfare that forces families into impossible choices. When your master bedroom stays at 62 degrees while your kitchen reaches 78, you're forced to set the thermostat high enough to barely warm the cold zones, which overheats everything near the heating system. This temperature inequality drives families to desperate measures. Space heaters running in bedrooms, thick blankets in living rooms, and constant thermostat adjustments that never solve the underlying problem. You end up spending more energy trying to compensate for poor heat distribution than Vikings used to warm structures 10 times larger with perfect comfort throughout. The mathematical reality of energy waste reveals why heating bills have become financial emergencies for middle-class families. Energy Star data confirms that typical forced air systems lose between 20 and 30% of heated air through ductwork before it reaches living spaces. But the bleeding doesn't stop there. Ducts running through cold attics and crawl spaces lose additional heat through conduction, warming empty spaces instead of occupied rooms. If your annual heating costs reach $2,000, $600 of those dollars are literally heating outdoor air, wall cavities, and unoccupied areas while your family shivers in poorly heated rooms. You're paying premium energy prices to warm everywhere except where people actually live. The health consequences emerge from forced air systems that move more than heated air through your home. National Renewable Energy Laboratory research documents how poorly sealed duct systems can distribute allergens, dust, moisture problems, and pollutants throughout houses, turning your heating system into a contamination highway. Leaky return ducts can pull air from crawl spaces, attics, and wall cavities, introducing whatever biological and chemical contamination exists in those spaces directly into your breathing air. Vikings dealt with smoke from open fires, but they weren't pretending their heating method was sterile. Modern systems promise clean air delivery while often degrading indoor air quality through cross-contamination from unconditioned spaces. The fragility cost becomes catastrophic during power outages and fuel price volatility. When winter storms knock out electricity, your expensive heating system becomes useless equipment that provides zero comfort. When fuel costs spike due to market manipulation or supply disruptions, families face choosing between heating and other necessities. Modern heating creates complete dependence on continuous energy supply and grid stability, leaving families vulnerable to forces completely outside their control. You can start documenting these hidden costs immediately with simple diagnostic steps. Seal major air leaks around windows, doors, and penetrations, then measure your energy usage reduction. Check return airflow in every room by ensuring adequate return paths exist, then monitor which rooms improve first. Use weather stripping and caulking to eliminate obvious drafts, then track temperature consistency improvements. These aren't minor efficiency tweaks. These are emergency measures to stop financial bleeding caused by heating systems engineered to waste energy, while keeping you perpetually uncomfortable and economically vulnerable. Now let me show you how to transform your modern home into a thermal system that works with physics instead of against it, using Viking principles adapted for 21st century safety and comfort. You can't recreate a smoky longhouse, and you shouldn't want to, but you can rebuild the same passive heat management that kept our ancestors comfortable through Ice Age, winters, using nothing more than intelligent design and natural convection. The first step requires creating a warm core space that becomes your thermal headquarters during cold months. This isn't about heating your entire house evenly, which is expensive and unnecessary. Choose the area your family actually occupies during evenings and focus on making that space effortlessly comfortable first. If you have an existing fireplace or wood stove, improve heat capture using blower kits where safe and appropriate, reflective panels to redirect radiant heat, and heat shields that prevent thermal loss through surrounding walls. Add thermal mass near the heat source using tile hearth extensions, stone or brick backdrops, or strategically place dense surfaces that store and slowly release heat. If you're dependent on central heating, use temperature setbacks and door management strategically, but ensure return air paths exist through transfer grills or jump ducts so you don't suffocate system airflow. Building controlled convection requires creating intentional high and low pathways that encourage natural air circulation between your warm core and adjacent rooms. Vikings used building height and roof openings to manage airflow through convection loops. Your modern version involves installing high pass-through openings where warm air can exit your core space and low return paths where cooler air flows back toward the heat source. Use quiet fans only when needed to prime these circulation loops, not replace them entirely. The goal is creating predictable airflow that moves heat naturally, rather than forcing it mechanically. Adding thermal mass safely means concentrating heat storage materials near your heat source without creating fire hazards or structural problems. Modern building science confirms that thermal mass smooths temperature swings by absorbing heat during peak firing and releasing stored energy as temperatures drop. Focus mass placement strategically rather than randomly, and pair it with proper insulation so stored heat serves your living spaces instead of bleeding outdoors through thermal bridging. If you're stuck with existing ductwork, prioritize fixing delivery losses through systematic leak sealing using proper mastic sealant and verified connections. Insulate ducts running through unconditioned spaces to reduce conduction losses that heat crawl spaces instead of rooms. During renovations, relocate ductwork inside conditioned space wherever possible so heat loss serves occupied areas rather than empty cavities. The clean air upgrade means keeping Viking thermal efficiency while eliminating smoke exposure through sealed combustion systems that draw outside air for burning, proper ventilation strategies that manage indoor air quality without destroying heating performance, and carbon monoxide alarms as non-negotiable safety equipment. Vikings didn't have better fuel or mystical fire knowledge. They had a better system where the building worked with heat instead of fighting it, making their heater a backup rather than a lifeline that controlled their comfort and consumed their income.